My name is Randy. I'm the Chief Engineer for BSL Eco Energy. So today I will be sharing with you guys on how we actually maximize the efficiency of our solar system. Okay. So before I move on, I will just briefly introduce what BSL actually does. Okay, so BSL Eco Energy is an EPC company. Basically, we offer total solution for the solar industry. And when I say total solution, I mean all the way from plant design, construction, procurement, commissioning, and we also supply, this is the main components of the system as well. Our factory is based in Rawang, and our sales office is in Glenmarie. So we have quite an extensive amount of experience in Malaysia as well as in foreign countries. So yes, if you have any requirements or if you have any solar projects which you need consultancy or you need us to come up with a solution, you can definitely look for us. Okay, so what's the deal with solar PV? You know, we've been hearing a lot about people talking about solar installations. You know, maybe your neighbors or your peers or your friends. You see, it's the answer to the world's energy woes, is it? I mean, people are saying that solar is the next thing in energy generation. Or people might say that Malaysia is great for solar because it's sunny all year round, although we have quite a number of days with rain, but generally speaking, we are quite a sunny country. Or you definitely might have heard people say that solar PV, the returns are guaranteed, is it? And minimal maintenance needed, it's very easy to do. And the ROI on solar is fantastic. But how fantastic is fantastic? Right? Sorry?
Oh, sorry.
I would say I personally do believe in time to come. We are still on the way there. Right? But is solar PV really the guaranteed investment that everyone is saying it is? Right? What do you guys think? Is it really? Yes, it is. But, you see, as with every investment, there's always a but at the back. Okay, so what determines whether the investment in the solar system is really worthwhile? Okay, so what are the factors that affects the profitability of a solar system? First will be the system cost, which will of course be how much you're going to pay for the system. And the value of the generated energy. The value is defined based on how much you are currently paying for your electricity. How much you consume. Because if you are not consuming, there is no point in generating the energy. Because right now in Malaysia, we have passed the FIT phase where we can sell the energy generated back to the grid. So right now we are in the net metering phase. So whereby we fully consume all the energy that we generate, and whatever extra, we will send it back to the grid and get credit for our subsequent bills. Okay. Next would be the location of the system. This will very much mean that the irradiation or whether the location is on islands or village. But generally speaking, in Malaysia, whichever location it is in Malaysia, we are a good country to have a solar system. Although in the northern states, they would benefit from better solar radiation as compared to the central and southern states. And another factor would be the amount of energy that can be generated. This will depend on the amount of the area available at your premise. Okay, but all this converts to the efficiency of the system. Why do I say so? Let's look at the component selection. I mean, component selection is one key point we have to look at when we are trying to maximize the efficiency of the system. On top of that, we also have to have a proper design. We have to make sure that the shading is minimal. System sizing is done right from the beginning. Manage our system losses because there is no system that is 100% loss-free. And the quality of work. Right? Proper maintenance is also very important because many people, when they have actually embarked on the journey of installing a solar system, maybe after the first month or two, you look at the performance, you monitor the system, you are very happy with the output. Then you tend to forget about it, let it be. But 6 months, 1 year down the road, the panels are going to get dirty, and your efficiency will significantly be affected. Okay, so this is just a very basic single line diagram, an outline of what a typical grid-connected PV system consists of. As you can see on the far left, there is your solar panels, this is your inverter, and this will be your main DB where it's connected to the load, and this will be the utility side where this is your energy meter. Of course, in between, right here, you have your combiner boxes, you have your AC distribution boxes where your fuses are, your protection, surge arresters are contained within. And every component in the system will induce a certain amount of loss, which is why it is important during design stage that we look into it and minimize it, right? So, first we talk about the efficiency of PV modules. Does the efficiency of PV module directly affect the output? Not really. Although we see in the PV module datasheet there is the efficiency figures for each module, but that really determines the amount of power you can generate for a given amount of space. For example, you have X amount of space, you can produce Y amount of energy. So with a higher efficiency, with the same amount of space, you can generate more power, right? But this is an example. Okay. If you can see, there is always the efficiency values. If you look at it, 19.11%. For each panel, you can get about 325 watts maximum power. If it's 18%, you get 320, and if it's lower, you get 315. This is what I meant by that. Okay. However, the installation of the PV panel does affect the efficiency of the system. How you install it, the method of installing, it plays an important role. Because many people, when it comes to installing solar panels, they just, what comes to their mind is slap it on my roof, let it work, that's it. Contrary, I mean, it's a bit contradictory, but solar panels have the highest efficiency when it's at 25 degrees Celsius. But you know, placing solar panels on your roof, you are never going to achieve 25 degrees Celsius, especially on a hot afternoon. So the hotter it gets, the lower your efficiency is. So this is the typical characteristics of a solar panel. And you can see Pmax temperature coefficient. What does this mean is, for every degree Celsius increase from 25 degrees Celsius, 25 degrees Celsius is the temperature they use to test the modules in the factory. So for every increase for every 1 degree increase, we are going to lose 0.4% of the power. Alright? Therefore, it is very important when you install the solar panels that you provide adequate ventilation beneath. Alright? Make sure that the panels are not heated up. It will get heated up, but at least if you have decent ventilation, at least the temperature is regulated. Because for every degree Celsius increase, as I mentioned, you're going to lose some power. Then comes to the solar inverter efficiency. This is the part where it directly affects the output of the system. When we are selecting inverters, right now in the market, if you go online and do a search for solar inverters, there are hundreds of brands. Many of them in the market. How do we know what is good? How come some are so cheap, some are more expensive? What are the different technologies? I mean, in a nutshell, inverters just convert DC power into AC power. Is that true? But that is true. Okay. But the efficiency and the reliability.
Bukan Iwan. Fiona ada, Fiona.
So this is a typical inverter, alright.
Semua sudah hantar satu. Sona S4 SIONG Siong.
And we have all sorts of different efficiency figures.
Semua C4 lah.
What's important is when we are selecting an inverter, make sure that they are tested by an independent body.
Bukan lori.
For example,
LPG punya.
TUV or for this particular brand, they are recognized by SEDA Malaysia. So
Đó là
with
PG
this
ni.
kind of guaranteed efficiency, you are at least assured that you are not going to lose a lot of power during the conversion. Because when
betul.
an efficient
Okay,
inverter
thanks,
does the
thanks,
conversion,
bye.
you lose a lot of power to heat, right? So shading is another important factor. A lot of people, they overlook this issue. They thought, I mean, if I shade a little bit of my panels, then it's fine. But, you see, therefore, studies actually show that when one part or more of the panels are shaded by a nearby object, just one part, trees, buildings of 9 degrees. So your power output reduced proportionally to the shaded area. For example, if I've shaded my panels by 5%, it means I'm going to lose 5% of my power. Is that true? Actually, it's not. It's a misconception. Okay? Studies show that just by shading one cell out of the 36 cells of a typical solar module, you can lose the power of the particular cell by up to 75%. Right? So it is very important to make sure that your shading is at minimal and make sure that there is no foreign debris on your solar panels. Okay, so just to put things into perspective, okay, this is the analogy of shading because as we know, if we are from an electrical background, we know that current in series is equal, okay, and every cell in a solar panel is connected in series. So if we were to shade one cell,
You can go in front.
is equivalent to a free-flowing water, and then you introduce a clog in the pipe. So the current of the entire string is going to drop. It's going to match with this, the current of this particular cell. Therefore, you're going to lose power for that particular module. And if you are a little bit more technical, you will understand that in a solar system, many of the solar panels are connected in series as well. Again, back to what I mentioned just now, current in series connection are constant. So if this panel is going to drop in current, the whole string is going to match this current. Therefore, your entire output of that particular string is going to be affected. Okay? This is just an example. Ohm's law says current flow in a series connection is equal. Right? Partial shading affects the entire string. So it is not true that if I shade 5% of my panels, I'm going to lose 5% of my power. It's going to be more than that. So pay very close attention to shading. So make sure we minimize the shading during design and installation part. Many times during installation, the location properly. I mean, if you have the luxury of space, you can choose wisely, do proper shading analysis, make sure that the shading is minimal. Choose panels with factory fitted bypass diodes. What this means is basically in today's solar panels, certain models, certain brands, they actually have bypass diodes installed within the panel itself. So what this does is when you shade a particular part of the panel, instead of bringing down the whole panel's current, you actually bypass the particular cell. So therefore, you only lose that little portion there, right? Instead of losing the power of the whole string. So this is also an important factor. Frequently check for debris on solar panels. We sometimes think it's on the roof. What can be on the panels? You'll be surprised by the things we actually find on panels. We even found shoes, we even found plastic bags, all sorts of nonsense and stuff. Right? So maintain nearby shrubs and trees. Today there's no shading doesn't mean there won't be any shading 6 months down the road. The trees, the shrub, or your neighbor might install a stroll, the satellite dish will be there. So it might cast a shade onto your solar installation, on your solar panels. So as I mentioned earlier, consider the ventilation, regulate the temperature. Because the higher the temperature, the lower the efficiency. System sizing. What's so important about system sizing? Every system has losses, as I mentioned earlier. The idea is to minimize the losses. A carefully designed system will have maximized efficiency and minimize its losses, meaning to say we choose the most efficient components, we size the system accordingly, and make sure that everything works in tandem. Because system sizing directly impacts the output of the system, which at the end of the day influences the payback period. Don't underestimate the cable losses in a typical PV system. This links back to what I mentioned about system sizing. So let's look at a typical scenario. Let me just give you a case study. Okay, let's say a typical inverter, a cheap inverter we can get from the market. The DC system voltage is 48 volts DC, alright? DC cabling from panel to inverters, from the roof, the cabling down to the inverters will be approximately 30 meters, let's say. And assuming they're using a 1.5 mm squared copper cables for the connection of your PV modules to your inverter. And the typical 1.5 mm squared is the internal resistance is 0.015 ohms per meter. Okay? And PV string, typically the maximum current flow is 9 amps. So what kind of losses do we expect here? Very simple calculation, Ohm's law. Voltage is equals to the current times the resistance. 9 amps times 0.45 is 0.45. We got this multiplied by the length. And we're looking at a voltage drop of 4.05 volts. And what is 4.05 volts? Just now we understand that the system is 48 volts. 4.05 volts is actually 8.4% in voltage drop. And looking back at Ohm's law, we understand that power is equals to the voltage times the current. So if you have 8.4% of voltage drop here, you can expect your power to drop. Okay. And this is only for one string. Imagine if you have a bigger system, 200 kilowatt, 500 kilowatt, 1 megawatt, the amount of losses you are going to see will be very significant. Okay, so all these losses simply because of an undersized cable. Therefore, it is very crucial, very important that we make sure that the system sizing is done right from the beginning. Okay. However, some of you might be thinking, okay, why not I just choose the thickest cable so my system will be very efficient. Is that true? Not really, because you need to balance out the cost of installation versus what you're going to get back from the solar system. You're going to spend a fortune on just the cables itself, then the whole project doesn't become viable. Okay, thicker cables aren't always the best option. And again, I just can't finish emphasizing that it has to be done right from the beginning. And one more thing you can look at to minimize cable losses is to look for inverters which has the MPPT feature. MPPT, it's a whole subject by itself. I will take 2 hours to go through it, so I won't go through it today. If you are interested, you can look to this and we can explain more. So basically, MPPT is what we call multi-point tracking. It can actually take in a significantly higher amount of voltage as compared to a typical converter. As earlier in earlier example, it was 48 volts DC. But a typical MPPT inverter can take up to a range of up to 850 or even 1000 volts DC. So what difference does it make if you choose something with a higher input voltage? If we look at the losses just now, 4.05 volts versus 48 volts, that is 7.2%. But if you take 4.05 volts and compare it to 850 volts, the percentage is very small. Therefore, your system losses is at a minimum. Okay? So, it is also very important to choose a trusted installer with good track record, because poor workmanship, poor cable termination, poor connections, and inferior materials also directly affect the efficiency of the system. This is a typical problem I've encountered many times. This is actually caused by poor crimping within the MC4 connector. A lot of contractors, they do not have specialized tools, they'll just use a plier and crimp it. If it's not secure, you won't see it immediately. During commissioning, it works fine, but over time, as the thing heats up, expands and shrinks and expands and shrinks, you will create a gap there will be sparks arcing, and eventually your connection will break down. And when this happens, you have the risk of fire, you have the risk of product damage. If it burns, you're going to damage your cells. And not to mention, before this even meltdown, during the arcing period or during the heating up period, you're losing power. It's being converted into heat. Therefore, you're already not maximizing the output of your system. Your output can generate this much, but because of this poor workmanship, it is affecting your overall output. Okay? So basically a low quality of work, will increase the system losses and operational costs because you need to replace your equipment, which directly affects your payback. And then this, end of the day, you think this project is not so viable after all. Determine the optimized frequency of cleaning. This comes to the maintenance portion that I mentioned earlier. It may look, over time, if you look at your panels very frequently, you will not realize the difference. You will look at this and you will think it's normal, it's fine, there's no rubbish, there's no bird droppings on it. But give it a wash, and then you will notice the significance of dust buildup on your panels. Okay, especially with locations, if your neighbor is doing renovation or you're in an industrial area, your panels will get dirty very quickly. So it is a good practice. You don't have to wash it every week. Maybe once a month you get someone go out there check. If you determine that your panels are starting to get dirty, get someone to just wash. Solar panels are very easy to clean. They are actually self-cleaning, but over time the dust hardens there. Just water, wipe, that's it, everything, and your efficiency won't be affected. Right? Also check for hotspots on PV panels. Sometimes there may be defects in the panel manufacturing. These hotspots could be also caused by spot shading, maybe the debris of a leaf or a piece of paper dropped on your panels long enough. Because as I mentioned earlier, when you shade a particular cell of a module, the current of the entire system drops. But where does the current go? It doesn't just disappear. It all discharges into the particular cell that has been shaded. And when that happens, over time, this cell will get shorted, it will be damaged, and we will not see it because the system will still work as normal. But this particular cell has been damaged, it's not producing, it is probably producing 20% of its intended power only. So oftentimes we will not realize that our system is underperforming. So this picture is taken with a thermal camera, which can very easily identify the hotspots on your panels. Of course, not everyone has a a thermal camera at home. So you can always look for companies that provide after-sales, maintenance services for your PV system. Right? So proper maintenance also includes regular inspection on connections, wiring, equipment, especially rodent damage. Cables are usually hidden within the roof, underneath the floors or covered in concealed truncates. So those are the places where rodents, rats, they love to hide. And when they come across wires, I don't know why, maybe rubber tastes good, they love chewing cables. And when they do so, if it doesn't sever the cable directly, you're gonna get an effect equivalent to an undersized cable, because they're gonna chew into the copper, and then you have a few strands left, and it's gonna heat up, and you're gonna lose power from there. Have a real-time monitoring system. Nowadays, there are certain brands, for example, the Disney inverter that I showed earlier on, there comes with a monitoring system. With an online real-time monitoring system, you can track the performance of your system as frequent as you want. You want to look at it every day, every hour, like when you're monitoring the stock market, or you want to look at it once a month, generate a report. From there, you can know whether your system is degrading faster than it should. So if you notice something is off, immediately you can work onto fixing the problem. Okay? Regularly trim surrounding trees and shrubs, as I mentioned earlier. So that's about it. So a properly designed and maintained PV system will maximize the returns of your investment and continuously work for many years ahead. So this answers the first question: is PV installation a viable investment? Yes, it is, but make sure it is done properly. Many contractors or many installers, they are just so focused on installing the system, finishing the work, and make sure it's running. But they forget that it is also their responsibility to maximize the efficiency and maximize the output of the system. Right? Thank you very much. Any questions you would like to ask?
Thank you, Danny. I must say you have given a very fair and balanced presentation, and I hope the audience has taken note of that. I agree with you that they are viable installations. There are two issues that I have. You put there about net metering expertise. I have certain reservations on what net metering is being done in Malaysia, and I disagree with the comment you said that PV is the future of energy solutions for the world, which it is not. And I can tell you that, for example, Malaysia's demand is 18,000 megawatts, and we have over 24,000 megawatts of installed generating capacity. If you want to get the energy Malaysia uses from the 18,000 megawatts demand, you will need 100,000 megawatts of PV with adequate storage, and it's never going to happen. Thank you.
Thank you. Of course, I agree with what you say, which is why I emphasize that we are on the way there. We're not there yet, because we never know, maybe 10, 20 years down the road, we may have the technology and the cost may have come down significantly enough that we can have such a solution for you. But of course, at the moment, we're not there yet. We know that energy storage batteries cost a lot, in fact, even more than the entire system. So right at this moment, definitely it's not the answer for our energy use.
Johan, the decrease of the efficiency at 0.4% per 1 degree, right? So over the years, how much has this reduced on the kind of technology?
Basically, you're asking that what is the trend of this percentage of loss for every increase of degree? It has been reducing steadily, I would say, not significantly. Previously, we have seen 0.49, 0.47 right now. Just a few months back, it was 0.44, and currently we are at 0.4. Several years. 6-7 years maybe. So definitely it will improve as manufacturers compete with each other to optimize their panels to make it more efficient. This figure will definitely reduce in the future. Yes, correct. Solar panels do degrade over time, and usually there is a certain guarantee by the manufacturers. For example, for the Seraphim modules that I presented just now, they guarantee a minimum output or a minimum capacity of 80% of its rated power at the end of a 25-year lifespan.
Is the problem caused by rodents biting on the cable a real problem, and is there a physical prevention for that?
This is a very real problem I've encountered many times. Rodents, they are naturally attracted to biting cables, I don't know why. So usually if you want to mitigate this problem, one of the solution people actually employ is to use metal piping for your cables. Of course, this will solve one problem but create another problem for you, because maintenance will be a bit tough, cost will be a bit high, and installation will be a little bit more tricky. So it's all about balancing. It really depends. If your area is rodent infested, definitely it's worthwhile to look into solutions like that. Or you can also put anti-roaming, or you can also put rodent deterrents around the area of your cable installation. Because unlike our typical housing cabling, those are all enclosed within the walls. But the PV system is usually installed after the building is completed, so therefore the cables are most likely exposed. Right? So the location and the way of installing and routing the cables will play a part in preventing such problems. Any more questions? Right, thank you very much. Our booth is just at Hall 1. If you have any further questions, please feel free to drop by. And on the way out, please do yourself a favor, pick up one of our files and folders. We have a lot of information inside. And thank you very much for your time.